Welcome to Brain Vision.
In this question, we are assuming uranium-235 breaks up into two equal fragments. So in this case, we have two nuclides with nucleon number of 236 divided by 2, and that is 118. So 118 nucleons in both fragments. You want to find what is the electric potential energy as they just separate. So I'm going to assume that they are just touching. So what we will need is the distance, right, between the centers of these two spheres, and we can estimate that by taking the radius, right, 2 times of the radius of these two nuclides. The radius can be found by estimating using R0 times a to the power 1/3, where a is the nucleon number and R0 is the constant, 1.2 times 10 power minus 15 meters. So this is the estimated radius. Then we can find the potential energy, which is given as 1/4 pi epsilon naught Q1 Q2 over R. And the Q in this case will be equals to half that of the number of protons in our uranium. So uranium has 92 protons, divided by 2, we should have 46 protons each. So the charge should be 46 times the elementary charge. And the R in this case should be 2R, right? The distance between the two centers. So all we have to do now is just substitute the values in. Q, remember, is 46 square times the elementary charge squared divided by 2 times of R0, which is 1.2 times 10 to the power minus 15 times a to the power of 1/3, where a is 118. Right. So epsilon naught is the permittivity of free space, which you should be able to look up online. The value, which is about 8.85 times 10 to the power minus 12. So evaluating this expression, you should get a value of 4.16 times 10 to the power minus 11 joules. And converting that into MeV, right? Since we want to compare with the fission energy, which is 200 MeV, we have to divide this by 1.6 times 10 to the power minus 13 joules per MeV to give us about 260 MeV. From here we can compare with the fission energy, right? That is 200 MeV. So the potential energy is about, by taking 260 divided by 200, you get about 130 or 1.3. So that is about 130%. So it tells us that the potential energy is 30% larger than the fission energy release.